Hello everybody, welcome back to an edition of the Control Expert Training. I'm your host, Leandro Mada, and in this video what we're going to see is how we can use the embedded Ethernet port of the Modicon M340 to exchange information to another controller. In this case, I'm going to use a Modicon M262 to communicate over Modbus TCP. Okay, so in this particular case, I mentioned I'm going to use an M340 with the Ethernet port. Okay, and on the other side, Modicon M262 going to the Ethernet port too. Okay, so let's go to the software. So on the M262 side, using the Machine Expert, okay, I have these unlocated variables. Okay, I just pointed directly to the registers, which is fine. So in order to do this, okay, it's important to locate the variables. In Machine Expert, we have variables that are unlocated, so we need to put in a specific place. Okay, so I have done a video about working with addresses and also working with the relocation table. That basically we put all the unlocated variables in two specific areas for reading and writing. Okay, so that can help you to make the connection. You start with the position 60,000. So yeah, it will work. Okay. If not, if you have already your application with sensitive variables, then you just point to the addresses, as I'm going to do. Okay, so this part is already finished for the M262. Okay, I got these 4 unlocated memory addresses. Okay, and now let's see on the other side. So on the M340, okay, when you double click on the Ethernet port, you don't have anything here. You just need to find the function for the TCP IP, and then you will need to have this net link. By default, it's going to be empty, so we need to link this to something. So if you go to communication networks, right click new network, you just need to select Ethernet, change the Ethernet name that you want to. Okay, and inside, I already created and name it Internet underscore M340. Here you just need to define the CPU or the device that you're going to communicate to. Okay, then something important is here. Once you selected the CPU, when you see the CPU, okay, you will need to check this, the module address. You can have this module address 0.0.3 or the name of the Ethernet link that you have created in order to do this. Okay. And something important is that we need to use those in order to access on the read and write bar function block. So inside this link that you have created, you have the IP configuration. That is where you're going to configure your IP address for the M340. Then you have security messages and all the stuff. We're not going to access into that. So once you configure the IP network, the network configuration for the M340, it is time to use the blocks. Okay, so in this particular case, what I have done is to use the I created a program, and inside the program I have the section with all the variables. So I didn't find that easy to work on function blocks when I wanted to do this, so I create a structured text in order to create some kind of a sequence. Okay, to read and write information from the other side. I can share this with you guys. So once you created the M26, the function for you to read the program or the section in order to add the blocks for read and write, it's important to know the different inputs and outputs that we have. So we have 2 main blocks, read bar and write bar. Okay, the read bar, there are a few things that we need to consider here. So read bar, the address, okay, we just need to use ADDM, which is a function block that that give us a structure for the block in order to know where he needs to point to. Then here we just need to use the link name or the channel that we're going to use. So we can use the Ethernet underscore M340 or this one, the module address 0.0.3. Okay, so we have that option. Then we need to put into brackets the IP address of the device that we want to communicate to. Okay, in this case, it's going to be the M262. The next option is the type of the variable that I'm going to read from the other side in this case. Okay, and here is a text, so we need to use text. And in this particular case, it's a %NW because it's just a holding register on the M262. Here is the number of the initial address on the other side that I'm going to communicate to. So in this case, it matched. There is no need for add one or subtract one. We just need to leave it as it is. So it's going to read the position NW10. So it's going to be this one. I should be able to read something different. Let's put 10 and 11. And here I'm going to 20 and 21. I believe this one should be able to change this to code. Yeah. So I'm going to read these two. Okay, so now I'm going to open again. This is the amount of numbers. And here, this is something important, is the variables that allow us to store the information that we're going to read, and then one for management of the block. Okay, so that one, if you go to interface here, so I have the data information and the management. Okay, they are starting from 1 to 4 of int, and I have these 4 variables here. So in order to know this, what it does, okay, there is the read, the online. So I have done a few things in order to simplify it, or I believe it simplifies the things. So the element number 3 is for the configuration of the timeout. Okay, so I have defined a variable for this. See, by 10, in order to have the timeout. Okay, so involves in reading and write. I have this guest, I believe it's gestion, or management for that function block. And then the other elements will have the number of executions, will have the errors, okay, communication error, operation errors, we have that information there. There is one, the first one will also, the first byte will tell us information when it's done, and so we have that here, and also when we need to abort the communication. So in order to trigger this, we just need to call the function. Okay, I don't really like to do this, but this is how it seems to work. But we just need to call this. Okay, and I'm going to finish the call after the standardized structure I'm going to show you. So that's it for the read bar. Then for the write bar, it's going to be the similar. Just need to define the address I'm going to communicate to, the port that we're going to use, this one, or we just need to use the Ethernet M340. Then here we just have the emis that I believe is for emit for the other side. Okay, the information you're going to send to the other device, to write into the device, and then the gest for the gestion or gestione, I really don't know. It's just for the management of the write bar function. Okay, so these two are similar. The important thing is how you execute them, how you use it. I can easily delete this if condition and just triggering, okay, but that will probably overload the communication channel of the M340. That's why it's important to have like a sequence if you're working on this, or probably use a NOC car or a NOE car, so you can use the IO scanner. That would probably be the best. But if you don't have the possibility to use that, then use the embedded Ethernet port, and we can do it in this way. So what I have done basically is like a sequence. So a state, using the case with this state variable over here. So basically I'm always in state 0, just waiting for one shot communication read and write, or a continuous read and write. Okay, so I should probably add this to here. I can share this with you guys, so you can check the code in case you want to. So I had the possibility to select if you want just one shot or continuous reading or writing. So after that, what you're going to do is to enable the read. It's going to enable this read. It's going to be always enabled until it is done. I receive the done signal or have a cancel. And this done came from here. So I have the first element .0 is the one that's going to tell me, okay, I have finished the reading. So what I'm doing here is to set the variable done until it finish, okay, and then here I'm going to delete. I'm going to put 0 to done because I was having issues when it finished, when it don't, because it next to the next scan is. So I do it in this way. So leave it outside the case. I should probably try to do it inside the case and wait, but yeah, I don't know. I didn't have the very good behavior, so I leave it outside. Then what I have done, once it finish, okay, or it's cancelled, if it's cancelled, you go to the first state. If not, it will continue and it will trigger the write, which is this one over here, okay, and then it will again check for cancel or checking for done. So now that I have this, let's try to make it run. Okay, so I'm going to put this like that. Just wanted to put this in a much better way. Okay, so now that I have this, I'm going to put myself up. I'm going to start reading and writing continuously. So here, 1. Here you can see that it goes through all the stuff. 10, and here is writing 69. So here I'm going to write 1. You can see there's already writing this information to the side. 222. It's writing. Now I'm going to make a change over here. 1, 2, 3. It's reading 1, 2, 3, and then 4, 5, 6. Okay. You can see it's reading and writing information quite easy. So what is important is to understand on the other device, in this case the M262, how are you going to let me just note this, put it on 0, so it just finished. So it is important to understand how are you going to make the sequence, okay, on the M340 and on the M262 where the information is located. Okay, so take a look on the videos related to the relocation table. That will help you. But on the, you can use the relocation table, or you can use the holding registers with all the values around the M262 to read and write. But if you put those information spread, it's going to be difficult for you, so you will need to create more sequence on the M340. But if you use, for example, the relocation table, you will have 2 main areas for you to read and write information. That will make the life much easier for you. So you just need to use 1 read and 1 write in order to make that, or just use read write bar from the other side. Okay, so this is how you can communicate using the embedded Ethernet port of the M340 with a M251, M241, or M262 device. Okay, programming machine expert. So thank you very much for watching this video, and I see you on the next one.